Next we are going to see difference of two standard deviation, right? Next test, large sample. So we know large sample is size always greater than or equal to 30. We'll see the test procedures and other formula with problem. So notations, n1 n2 we know population size, capital N1 n2, small n1 n2 sample size. Sample means x1 bar, x2 bar. Mu1 mu2 population means, sigma 1 sigma 2 population standard deviation, small s1 s2 sample standard deviation. First we need to calculate the test statistics, that is z value, calculated value, that is equal to formula s1 minus s2 by root of sigma 1 square by 2 n1 plus sigma 2 square by 2 n2. If sigma 1 and sigma 2, that is population STs, are given, that is equal to, suppose s1 s2 are given, then you have to replace sigma 1 and sigma 2 by s1 s2, right? Z is equal to s1 minus s2 by root of s1 square by 2 n1 plus s2 square by 2 n2. So if the standard deviation, sample standard deviation is not given directly, instead of sum of squares sigma xi minus x bar square is given, then the sample variance is use this formula. If they have not given directly the standard deviation, you have to calculate the standard deviation using this formula. S square is equal to 1 by n minus 1 sigma xi minus x bar the whole square. Defining hypothesis, we know the standard result. So two tail, right tail and left tail, the table value always same, right? Step 3, conclusion. So same one, calculated value is always less than tabulated, then H not accepted. Greater than means if it is in the other way, H not rejected, right? So the procedure are same like previous test. Confidence interval formula s1 minus s2 plus r minus z root of sigma 1 square by 2 n1 plus sigma 2 square by 2 n2 if sigma 1 sigma 2 are given. Otherwise s1 minus s2 plus r minus z root of s1 square by 2 n1 plus s2 square by 2 n2 if population SD are given. Sample SD, right? So here not population, small s1 s2, the sample SDs are given. Change that, typo error. To find the standard error SE, which is equal to root of sigma 1 square by 2 n1 plus sigma 2 square by 2 n2. Suppose if you are having population standard deviation, the formula is root of s1 square by 2 n1 plus s2 square by 2 n2. So first problem, a man buys 100 electric bulbs of each of two well-known makes, right, taken at random from stock for testing purpose. He finds that makes A has mean life of 1303 hours with standard deviation 82 hours and make B has mean life 1248 hours with standard deviation 93 hours. Is the difference between sample standard deviation is statistically significant, right? Given sample size both are same, 100 bulbs each, bulb A and bulb B. So n1 equal to 100, n2 is equal to 100. Sample mean they have given, right? Lifetime, average lifetime of A and B. So x1 bar 1303, x2 bar 1248, and also the standard deviation, sample standard deviation also given. S1 equal to 82, S2 is equal to 93. So hypothesis, there is no significant difference between the standard deviation. So sigma 1 equal to sigma 2, right? So H1, there is a significant difference. We are using two tail, right, between standard deviation, right? So let the level of significance be 5%. Test statistics Z is equal to S1 minus S2 by root of S1 square by 2 n1 plus S2 square by 2 n2. Substituting the values, 82 minus 93 by root of 82 square by 2 into 100 plus 93 square by 2 into 100. So you will get minus 1.2547. So calculated value, you take the positive value, that is modulus value, that is 1.2547. Tabulated value we know as per the table at 5% level 1.96. Now conclusion, comparing calculated and tabulated values. So calculated value is less than the tabulated value, therefore H0 is accepted. So there is no significant difference between the standard deviation. Thanks.